Hi guys. Okay, let us continue from where we left behind. In my previous video, I have discussed about the concept of periodic table, the classification of periodic elements, what are groups, what are periods, the periodicity, and the 5 different periodic properties that we are going to study. I just discussed the names of it. Today in this lecture, I will be discussing about the 5 properties in details. So, what are the 5 properties? The 5 properties that are: number 1 is atomic radius, second is atomic ionization potential, electron affinity, electron negativity, non-metallic and metallic characters. So, let us begin with discussing the metallic atomic size first. Before understanding the concept of atomic size, you need to know what is atomic radii. Okay, I am taking this as a nucleus of the atom, and this is the outermost shell of that atom. The distance between from the nucleus to the outermost shell is called the radius, that is r, as depicted by this sphere. Okay, and now you know size means the volume of an atom, and the volume of a sphere is always given by the formula 4 by 3 pi r cube. Now, the basic thing that you would be easily understand is that as the size or as the radius of the sphere would increase, the volume would increase, or rather I would say as the radius increases, I can say the atomic size of an atom will always increase, and this atomic size is measured in the unit of angstrom. Okay, we need to know what are the factors which will be detrimental in affecting the atomic size of an atom. There are 2 main factors which will be deciding how the atomic size varies. The first one is the number of shells. Okay, number of shells means, what are number of shells? Shells are nothing but the orbit in which the electrons are placed. As the number of shells, I am writing shells as S, increases. Suppose take this example only, the diagram which is shown here. If this is shell 1 and another atom will have shell 2, its distance has increased from the nucleus. As the distance has increased, that means I can say the radius has increased. Since the radius has increased, I can say the volume of the atom will increase. So, I can say the atomic size increases. So, what is the basic underlying concept? As number of shells increases, atomic size increases. ठीक है, यहाँ तक क्लियर हुआ? What I am trying to say is, from the as you go more away from the nucleus, as a distance increases from the nucleus, the volume of the sphere or the atoms increases. ठीक है, यहाँ तक सिंपल था. Next concept is the nuclear charge. Just a second, I'll rub it off, then I'll say what is a nuclear charge. You know, in an atom or in the nucleus of an atom, what are present? A nucleus, sorry, just a second. A nucleus will, this is a nucleus, it will have proton plus neutrons. Okay, since neutrons have no charge, obviously the overall charge of a nucleus will be due to the presence of protons, which is positively charged. Okay, and electrons are negatively charged. So, obviously you know opposite charges attract. Greater the positive charge, greater the number of negative charges, more strongly they will attract each other. Okay, Now, if I increase the positive charge, I can say as the positive charge increases, it will more strongly pull the electron towards itself. As it is pulling the electron towards itself, the outermost orbit electrons have been attracted towards the nucleus more. As the electrons are getting more attracted, the distance, this distance will decrease. Okay, so what is the concept? Nuclear charge increases, distance between nucleus and electron decreases, atomic size decreases. Why? Because with increasing nuclear charge, electrons are pulled towards itself, they are coming closer. As they are coming closer, the distance from the nucleus and outermost will decrease, radius decreases, atomic size will also decrease. Clear? Very simple concept. So in brief, we can say that about the two factors. Number of shells increase, atomic size increase, nuclear charge increase, atomic size decrease. Now we will see how these factors vary while going across the period and down the group. That means we are going to discuss the trends along the horizontal lines and the verticals. Let us first discuss the atomic size trend across the period. It's very simple, very easy, nothing to mug up. You just need to understand the concept. You will be able to write out the reason based questions which comes from this portion. If you just need to know the factors, if you are clear with the factors, you will be able to solve any difficult question which comes. However, no such difficult questions has been asked from this portion yet. Let's move with the trends. I have said in my previous video also that in across the period, when you are going from left to right, number of shells never changes. There is no change in the shell number. Means period 1, all the elements in the period 1 will have same number of shells. Okay, so this factor will not affect any affect the atomic size. So you cannot distinguish elements, or you cannot justify a reason why an element, particular element A is having a smaller radii than element B. So what is changing is, across the period, one factor which changes is the nuclear charge. It increases along the period. Okay, because why will the nuclear charge increase? It is because across the period, when you are going, atomic number is increasing, and you know atomic number is equal to the number of protons. So if number of protons are increasing, the positive charge is also increasing. As the positive charge density is increasing, so the nuclear charge will increase. Such a simple concept. Now as the nuclear charge is increasing, the distance, more strongly the electrons will be pulled towards itself, stronger bond will be, attraction will be there, and which will pull the electron towards itself, and the size of the atom will decrease. Simple. But one thing very important for the noble gases, they have completely filled orbitals. Suppose I am taking example of neon. Atomic number is 10. So this is a nucleus, first shell, second shell. It will have 8 electrons. 8 electrons because configuration is 2, 8. please do practice writing the electronic configuration of first 20 elements. It will be very useful for you while answering the questions. So because of presence of this 8 electrons, there will be an electronic repulsion. As this repulsion, they will tend to pull apart. That means they will move away from each other. As they are moving away from each other, their volume increases because distance will increase, the radius will increase because they are moving away. They are pushing the shell to move away from each other. Distance increases from the nucleus, so the atomic size increases. Very important to know. Means suppose I have given it, why I am teaching you this question is, if I have given you suppose 3 elements, marking it as lithium, carbon, neon, and I have told you to arrange these 3 elements in the increasing order of their atomic size. Definitely what you would have done is, from the simple concept, across the period atomic size decreases. So neon, carbon, lithium. This is wrong. It will be carbon, neon, lithium. Okay. Why not neon ahead of lithium? Because then this factor will dominate over the repulsion factor. Okay. So what is the trend across the period? In short, let's sum it up. Atomic size decreases across the period. Okay. Why? Because of nuclear charge increases. Okay. Because the number of shells factor does not affect it. Now let us see the trend down the group. How will it change? How will it vary? In previous lecture also I have said, down the group, as you go from top to bottom, the number of shells will increase. Okay, as the number of shells is increasing, then your atomic size should increase. Simple. Number of shell increases, atomic size increases. Here also nuclear charge increases. Okay, down the group nuclear charge also increases. The atomic size should decrease, but we do not see this trend. The atomic size does not decrease, it always increases. Remember this. Okay. What we will say is, between these two factors, the number of shell increasing factor dominates over the increase in nuclear charge. Okay. Suppose you have 2 factors upon which you need to determine which will be more effectful. Here number of shells factor will overshadow the effect of the nuclear charge factor. Okay, clear, simple. So what is the whole concept of atomic size? Atomic size is nothing but the distance from the nucleus to the outermost shell. How will you determine? What are the factors which is determining the atomic size? Number 1 is the number of shells, second is the atomic nuclear charge. If number of shells increases, atomic size increases. If number of nuclear charge increases, atomic size decreases. What is the trend across the period? It decreases. Why? Because shell have no effect role to play in it. only the factor which will be determining the atomic size across the period is the nuclear charge, which increases. But when we are determining for the group, down the group, we see number of shells increases as well as the nuclear charge increases, but the nuclear number of shells increasing factor dominates over the nuclear charge factor, which is why the atomic size increases down the group. Clear?
Thank you everyone. Please do like my video, share and subscribe it.